Okay, so let's start first with the first reminder I want to share with you from Danda. Uh, the first thing is the solution for Tuesday session was shared under week 2 forum, if you can see it. So the solution for week 2 is there. Okay, you can open the file and have a look on the solution of week 2, Tuesday session. Okay, and another reminder about the formative quiz. The formative quiz you can find under assessment. So if you click assessment under assessment 1, so we have assessment 1, part A and part B. Part A, we have a formative version of the quiz, so you can practice as much as you can to prepare for the summative quiz. Okay, so I just want to encourage you to try or attempt this formative quiz if you haven't yet. I want to ask if you have tried it, Jonathan and Camilo. Have you already? You okay? Okay, that's good. Thanks for confirming, guys. So if you haven't attempted this quiz, please try to attempt it as soon as possible. So it will help you to do well in the summative quiz, part A and part B. Okay, so now I will start going through the tutorial question or the question we have for Thursday session. So as you can see, we have some examples of the formative quiz. Sorry, I hope you can see my screen now. Okay, so we have some example of the formative quiz for trigonometry and other equilibrium of forces and so on. This will help you to understand the question of the quiz and the following weeks of the content of the course. So I will go through these questions one by one, and please let me know if you have any question or any query, and I will clarify more for you. Okay, so let's start now. Okay, so this is our first problem of today. So our first problem, we have a triangle with a right angle here. If you can see the right angle, and we have, as you know, three uh three lines forming this triangle. The first one, right, is A. The length of this one is A, and the length of this one is hypotenuse. So we have A and hypotenuse and B, and we have the angle between these two lines is theta. So we have theta. Theta is between A and the hypotenuse. Actually, for the angle theta, if this is our triangle, this is theta. So the line beside the angle is called adjacent, and the line opposite to the angle is called opposite. And the line opposite to the normal angle or the right angle is called hypotenuse. Okay, so this is from trigonometry, and it is important for us to know it. So let's look at our example here. In the drawing below or the triangle below, what is cosine theta? So we are looking for cosine theta for this triangle or for this angle, sorry. So do you know what is the formula for cosine? The formula for cosine is the adjacent of the angle divided by the hypotenuse of the angle. So in this case, if we are looking here, so what is the adjacent A? So it will be A over the hypotenuse. Okay. So to know the cosine of this angle, we need to know what is the hypotenuse and what is A. If we look at the question, so we have A given as 1.19 meter. So A equal to 1.19 and the hypotenuse is 7 and the hypotenuse equal to 7 meter. So in this example, cosine theta will be the adjacent or A over the hypotenuse. This will be 1.19 over 7. This is given to us in the question head. And the answer will be 0.17 or 0.17. So cosine again theta for this angle theta, the cosine will be the adjacent over the hypotenuse. Okay, is it clear? Okay, so another one, not required in this example, but just to practice. What is sine theta? What is sine? Sine theta will be the opposite of the angle
Opposite
over the hypotenuse,
Mm.
right?
Mm.
Yeah, thank you, Camilo. So it will be B over hypotenuse, okay?
Mm.
But we don't have B given to us. So what we need to do, find B. Do you know how to find B? What is given to us? What is given us A equal to 0.119 and the hypotenuse or H equal to 7 meter. Can we find B? What theory we can use for that? Pythagoras? Pythagoras?
But, sorry, I'd make B the subject, and we know hypotenuse 7.7, so multiply 7 times sine theta, and we know what theta is. We calculated what theta was in the previous one, didn't we?
Yeah, we can, yes.
Yeah.
There is a lot of method. Yeah, we can follow what you have mentioned. Can you tell me again?
Yeah.
What you think about it? Other option is to find theta directly.
Mhm.
So how much theta?
Theta is the cosine of 0.7. Wait a second.
Yeah, so theta will be sine minus 1, the value we got, or the adjacent over what? The
Yeah.
hypotenuse, which is cosine minus 1.17. So the angle theta from this calculation equal to 80.212 degree
Yeah.
or 80.2 degree
Mm.
if it is the required answer. Is that okay?
Yeah. Yeah.
So if the dimension is not ready, so you can get it from the trigonometry function, or you can again also find B. So you have a lot of ways to find it. But if this way is easier for you, so it is better as well. So because we already know cosine theta, or we know one of the functions, so we can find the angle theta, and
Mm.
then from the angle theta, we can find how much sine theta. So
Mhm.
sine theta will be
80.
sine 80.2
Yep.
degree, which is
0.95.
yeah, 0.985.
Yep.
Yeah, same answer, Camilo?
Yep.
Yep, all good. All good, Jonathan? Okay, so that's it for, actually here we only need cosine theta, so the answer will be 0.17. But I just try to practice more function with you, okay? So this for our first question. Let's look at our second question for today. So it is again trigonometry. So we have angle, right angle. This is the right angle. We have the adjacent to the angle theta A and the hypotenuse there. The given or the question head mentions that what is the length of the hypotenuse? So the question asks for the length of the hypotenuse, where theta is given as 0.37 degree. So given theta equal to 0.37 and the length of the adjacent A equal to 13 meter.
Mm.
So what we know here in this example, we know the angle and we know the adjacent, and we are looking for what? The hypotenuse.
Mm.
If I ask you what trigonometric function linking between the angle and the adjacent, is it cosine or sine or tan? I will remind you, if we have if we have triangle, so we have again adjacent, opposite, and hypotenuse, right? So the function cosine equal to the adjacent of the angle over
Mm.
the hypotenuse, right? What is sine?
Opposite.
Opposite over hypotenuse, right?
Mhm.
What is tan?
Is it opposite over adjacent? I can't remember.
Yes, yes. It is sine over cosine
Oh, okay.
or opposite over adjacent,
Yeah.
right?
Yeah.
So this is our three main trigonometric function. So if you need to use them, so highlight them.
Can I ask you a question? I always forget this. I don't know why. I mean, I know where the formulas are, but I can't. I can. It's been what 40 years. I've never managed, or 60 years. I've never managed to remember these. How do
Just
you
to
remember
practice,
them?
maybe you are not using it frequently. That's why.
Oh, okay. Yeah.
Yeah,
Yeah. No, I don't
yeah.
use.
You know, when you don't use something, you forget it. That's the only the problem.
Yeah.
Yeah. Okay, so if we are looking to our example here, what is the link between the angle and the hypotenuse and the adjacent? Which function? I think cosine, right? So as you know, or from this, we know cosine theta equal to the adjacent over the hypotenuse,
Mhm.
right? What we know that the angle theta is 37. So cosine 37 equal to how much is the adjacent given here?
But 13.
13 meter,
Yeah.
and the hypotenuse is not given. So cosine will be equal to 13 meter over the hypotenuse, right? So how can we find the hypotenuse from here?
I would have done it the other way around. I would have just said hypotenuse equals
Yes. Yeah,
just
I will
adjacent adjacent
try
over.
to refine it again, right? Yeah.
Yeah.
Yeah. So the hypotenuse equal to what?
Adjacent over cosine 37.
Yeah. 13 meter over cosine
37.
37 degree.
Yep,
So it
that's right.
will be 13 meter over cosine.
Yep.
You know how to do cosine? I
Yeah.
want to show you
Yep.
one.
0.798.
Thank you, Jonathan, for sharing your answer. Thank you. So I will share with you the calculator.
16.29
Yeah, I
meters.
just want you one. Have you used Desmos calculator before? The scientific calculator? You can see it?
Yeah.
You can use your scientific calculator, no problem, but I just want to share it with you if you want to use it. So we have cosine and 37. What is the value? Can you see the value?
Yeah.
0.798. Okay, so I will return back to. Can you see the screen now?
Mm.
So we have cosine theta equal to 0.798, and we have the adjacent as 13 meter. So the value will be 16.277 meter, or to, if we round it up, so it become 16.3 meter. Because we need the answer, or the answer will be accurate up to 1 decimal place. So you can write it as 16.3. But if you want to write it as detailed as you want, it's okay as well.
Mm.
Okay. Do you have any problem with this one? Easy? Yeah. Okay, that's good. Okay, so let's jump to the next one. So the next one will be about finding the component of inclined forces. Okay. This also depending on what trigonometric functions, like tan, cosine, sine. Okay. So if we look at this example here, or this question here, we have at point O, force F equal to 52 kilonewton. So we have F equal to 52 kilonewton, and this is our point O. Okay. What else? In the direction shown in the diagram below, where A is 10 meter, B is 12 meter. So A and B are the dimension of the triangle, including this inclined member. So A given as how much? 10 meter, and B given as 12 meter, right? The requirement is to find the component, the vertical component and horizontal component of F. So as you know, it is hard to deal with inclined forces. Inclined forces is hard to deal with in our analysis. So what we need to do for inclined forces, we need to make our analysis to find vertical component and horizontal component. Okay, so any force can be analyzed to two component, vertical and horizontal. Okay, so in this example, this force F, we can mention or can assume that we have two component for it. The first one is the horizontal one. I will call it F horizontal or FHOR. And the other component will be vertical, and I will call it FVER or F vertical. So the inclined force F will be analyzed to the two component V vertical and V horizontal. Is that okay? So how can we do that? We can do that using the trigonometry function or trigonometry angles here. In this triangle, we have this angle is theta between the force F. This is our force F and the horizontal line or the horizontal direction. So the angle theta is the force between the horizontal direction and the force F. Okay, and from the geometry, we know that, or we understand that, what is this angle is? This angle is the right angle between the vertical and horizontal. This is a right angle. Okay, so using the trigonometry, we can find the component. So if I draw this triangle outside here, so we have, this is our force F, 52 kilonewton, and we need to find these two force, V horizontal and V vertical. Okay, and the given information that this is theta, this direction or this side of the triangle is 12 meter, this side of the triangle is 10 meter, this is B, and this is A. So A, 10 meter, B, 12 meter, this is a right angle. So how can we start? to analyze, we need to know the trigonometric function. So to know the trigonometric function, we need the angle theta. Do you know how to find the angle theta here? So in this triangle, we know theta, this 12 meter, this 10 meter. So can we know theta? There is many ways to find theta. One of them is to find the hypotenuse first.
Mm.
If we find the hypotenuse, this one option. Can you find the hypotenuse?
Yes.
How?
Hypotenuse will equal the square root of a squared plus b squared.
Yes, so if this B, this A, so from Pythagoras theory, we have the hypotenuse equal to A squared plus B squared under the square root, right?
Yep.
So the hypotenuse in this example will be root 10 squared plus 12 squared under the root.
Mm.
So it will be the root of 244, which equal to 15.62 meter. Is that okay? Is that clear?
Yeah.
Okay. That's good. So we find the hypotenuse as 15.62. So now can we, if I ask you how much sine and cosine, can you find sine and cosine?
Mhm.
Yep. What is cosine?
It'll be 12 over 15.62.
Yeah, just to remind you again, what is cosine? Adjacent over hypotenuse, right?
Yep.
So it will be, what is the adjacent to theta, if this theta? So the adjacent is 12, right?
Yep.
So we have adjacent 12 over hypotenuse 15.62, and we find it as 0.768. So this is cosine theta.
Hmm.
If I ask you what is sine theta?
Opposite over adjacent over hypotenuse.
Yeah, opposite over hypotenuse.
Yeah.
What is the opposite? Opposite is
12. No,
10.
so it's 10.
10. Yep.
10.
Opposite is 10. So it will be 10 over 15.62. So it become 0.64.
Mm.
So if this is sine and cosine.
Mm.
Okay, Jonathan? All good, Jonathan?
Mm.
Yeah, okay. So if this sine and cosine, so we now know the trigonometry. So as you know, the vertical component and the horizontal component will be using the trigonometry function. So if we have this here, so this is our force F. So the blue one is our F horizontal component, and the green one will be our vertical component. So we know how much is the angle we have. We have, this is theta, okay? So the horizontal component will be, if this F, the horizontal component will be F cosine theta. Why F cosine theta? Because cosine theta is the angle between the horizontal and the force, right? So the horizontal component is cosine because this is the closest component uh, to the angle.
Mm.
Okay, so the closest component to the angle is cosine. So the horizontal, F horizontal, will be F times cosine theta. So F is the force, and cosine theta is the angle between the force and the component. Okay, so Horizontal, take cosine in this case. Why take cosine in this case? Because this is the component close to the or near to the angle. So if I ask you what is the vertical component is or what it should be equal to from this using this theory. Because we have two options. We have two options. I will tell you one. If we want to use only one theta or one angle, so the vertical component is close to the angle or far from the angle?
Far.
Far from the angle. So the component far from the angle takes sine. So F sine theta. So why it is sine? Because the vertical component is far from the angle. So the component near the angle take cosine. The component far from the angle take sine. Is that clear?
Mm. Could you is it Mooney? No, who's speaking? Ahmed?
Yes.
Ahmed. So could you do cosine, but you do the 90 minus the angle?
Yes, this is the second option. But the idea is you would need to find the other angle. So I know Dan that mentioned this in last session. I want to show you another solution, but both of them are correct.
Yep. Okay.
90 sine and cosine are related together. So you know the like angle and the 90 minus, so they are completing each other. So also sine and cosine completing each other. Okay,
Can
but
I
this is
can I just go back to your triangle at the top? I just want to understand something. So you know when you do the triangle up here, you got F horizontal and you got F vertical. How did you work out that the F horizontal was the adjacent and say not the opposite?
yes here. So
Huh?
here,
Yeah.
this is our horizontal, right?
Yeah.
And this is our angle.
Mhm.
So which one is the adjacent? This is the adjacent
The
to the
adjacent is
angle
always
theta.
the horizontal. Is that right? Always, no matter what direction it's going, whether it's going left or right, it's always adjacent.
Yeah, it doesn't matter the right or left.
Okay. And the vertical, whether it's up or down, it's always
Yeah. The
okay.
direction is not important in this.
All right.
The direction only because this force is going down, right?
Yeah.
So if
Uh-huh.
you analyze it, so this is the two component of it.
Yeah.
So the horizontal component will go left
Yep.
and the vertical component will go down.
Yep. Got it.
Okay.
Yep.
Okay, so if we return back to here,
Yep.
so we have V horizontal and V horizontal will take cosine theta and V vertical will take sine. Another option, as you mentioned or as you know,
Mhm.
is if we have the angle alpha, for example. So what is the angle alpha? The angle alpha between the force and the vertical component. But
Yeah.
now you need to find two angles.
Mm.
So if this theta, so phi alpha will be equal to what?
90
Alpha will be 90 minus
theta.
theta.
Yeah.
Okay. So if you have theta, you find alpha 90 minus theta. So in this case, the vertical component will be close to what? To
Alpha.
alpha. So vertical component, another option equal to F cosine alpha.
Okay.
So F cosine alpha and F sine theta will be equal values.
Yep.
So if you want to work all the problem with one angle, so one component will be sine, one component will be cosine.
Okay. Yeah.
If you have the two angles, so both of them will be cosine, but you need each component, this component, for example, here,
Mhm.
the horizontal component,
Mhm.
close to what?
Yeah.
Close to theta, so it become F cosine theta.
Okay.
This component, the vertical component, close to alpha, so it become F cosine alpha.
Okay.
Okay?
Yeah.
So now if we want to find the solution of this one, so the F vertical will be equal to what? F
F sine theta.
sine theta.
Yeah.
What is sine theta from top here? We found sine theta as
0.6.
0.64.
Yeah.
And what is F?
50.
F is 52. So we
50.
have F 52
Yeah.
and we have sine theta 0.64.
Yeah.
So we have F sine theta equal to 52 kilonewton times 0.64. So
Explode.
this gives us the vertical component as 33.29 kilonewton. Kilonewton is the unit, as you know, and 33 is the value. If you want to write it to the nearest first decimal place, so it will become 33 point what? 3
Yeah.
kilonewton.
So round up, yep. Got it.
If I ask you what is the direction of it, Camilo?
It's vertical, it's going down.
Yeah, downward. So if you want to show the direction, not in the quiz, but I mean generally, so this component is going down.
Down, yep.
Okay,
Mm.
because this come from here. So the green one or the
Yep.
vertical component go down,
Mhm.
and the horizontal go to the left.
Yes. Yep, yep,
Okay.
yep.
So if I ask you, how much is the horizontal component? The horizontal component is F times cosine theta, because theta is nearest
Hmm.
is the nearest angle to the horizontal component. So it become F cosine theta.
Theta. Hmm.
So it become 52 kilonewton times cosine. How much cosine from our first
0.7.
calculation?
So 41 point
Cosine theta
three
is 0.768.
six. Yep.
So 52 times cosine theta, which is 0.768.
Mm.
So how much is the value?
41.28. No.
Thir-
Isn't it?
39 or 31? You mentioned 31?
No, wait a minute. 0.789. It's 41.028.
Yes. Okay, so if you use the actual value, so 0.76, it is 0.768.
Oh, sorry, wait a minute. I got the wrong thing
Yeah.
here. 68. Sorry.
So
39.974.
yeah, okay. So the accurate value is 39.936 kilonewton, right?
Yep.
If you write it to the nearest one decimal places, become 39.9 kilonewton. If I ask you what is the direction, Jonathan and Camillo, it is to the left,
Left.
horizontally to the left.
Left.
Oh, we are talking about the horizontal one, Jonathan.
Yeah.
Yeah, to the left. Thank you. So it become to the left
Mm.
and 39.9.
Mm.
So for any calculation of forces, you need three things. First is the magnitude or the value.
Yep.
What is second? The unit. What is third?
The
The
magnitude,
direction.
the direction, yeah.
Yeah,
Yep.
so we have unit, magnitude, and direction. Three
Yep.
things.
Yep.
Okay.
Yep.
All clear for this example?
Mm.
Okay, thank you. If you have any question or you need any clarification, just stop me and I will try to say it another way.
Uh-huh.
Okay.
All good.
Okay, so I have another question, but this one for equilibrium or stability. So it is very simple one, but just quickly we have a look on it. So what is the requirement of this question? Acting at point A are two forces, F1 equal to 183 kilonewton to the left. So if I interpret this one, so we have one force, F1 equal to 183 to the left, right? And F2, which is 24 kilonewton acting to the right. Another force, F2 equal to 24 to the right.
Hmm.
So because they mentioned to the left and to the right, so they are vertical or horizontal or inclined forces.
So it
Left and right, so it is horizontal forces, right?
cancels.
Sorry?
It cancels out, doesn't it? It's it's opposite, doesn't
Yeah,
it?
opposite direction, but I mean just why not vertical? Because they mentioned left and right. This is what
Yeah.
I want to clarify.
Yeah.
Okay, so if we are interpreting this, I will interpret this again here. So we have point A, we have two forces,
Mm.
F1 to the left,
Mm.
183 kilonewton.
Mm.
Another force, green, to the right, F2 equal to 24 kilonewton. What is the question want? The question want to find how much the resultant force R, if it is to the left or to the right, but I will assume it to the left. How
Mm.
much R? So how can we find R? Do you know how to find R?
Subtract,
R will be the
isn't it?
the summation of these two forces, or the like if we
Yeah.
sum them up. But because they are opposite direction, so the addition, it will not be addition, it will be subtraction, right? Okay, so before we start, I want to show you something. We have like agreed positive direction for forces in X and forces in Y. What is the agreed positive sign? To the right of X is positive,
Mm.
to the top or above upward is positive for Y. So Y upward positive, X to the right positive. So if we have the opposite directions, so we have here and here. So this is negative Y, this is negative X. So X to the left negative, Y up downward is negative. So if Y downward or X to the left, they are negative. So what is the right directions? Or sorry, what is the positive direction? This is our positive direction. Is that clear?
Mm.
Okay, so now when we apply in the formulas, this F1 positive or negative?
Negative.
Negative. Why negative?
It's going left.
Because this to the left. It is
Negative
the
X.
opposite of our agreed direction.
Mm.
So what is F2? Positive or negative?
Positive.
Positive, because it is to the right.
Mm.
So if we want to find R, R is the abbreviation of the resultant.
Mhm.
So the resultant will be 183, or let's say it in a different way first. It will be F1 and F2. It will be like algebraic process between F1 and F2. F2, because it is to the left, so I will give it negative sign. F2, sorry, because it is to the right, I will give it a positive sign. So is this clear?
Mhm.
Okay, so R will be negative 183 kilonewton plus 24 kilonewton. These two signs, again, because of what? The direction. To the left and to the right. Okay? So how much is the resultant, do you think?
Minus
Negative,
one.
yeah,
Yeah. I was going to
minus.
ask you, can you have can you actually have a negative force? Is that possible?
No, no, negative is just a direction.
Yeah, I know it's not possible. Yeah. Okay.
Yeah,
Yeah.
yeah.
All right.
So it is just the magnitude is again 159 as you mentioned,
Mhm.
but just if it is to the right, it will be positive.
Yeah.
If it is to the left, it will be negative. Instead of mentioning 1/4,
Yeah.
158 to the left and 158 to the right, they put the sign. So you understand it is to the left without mentioning it.
Mm.
Okay. So what is the value you got?
Minus 161. Oh no, sorry, minus 159.
59. Yes. Minus 159 kilonewton.
Mhm.
So I will ask you a question here, Camilo.
Mm.
What does this sign means?
To the left,
Yes.
159 kilonewtons.
So this means we can write it again. R, or the resultant equal to 159 kilonewton to the left.
To the left, yep.
Or by arrows, I can put this arrow
Okay.
here.
All right. Yep.
Okay.
Mm.
So the value is 159, the direction to the left.
Yep. So you can't really use minus 159 as a notation. That's not technically correct. So you have to say it's 159 to the left. Is that right?
Yes.
Yeah.
Yes, because or another way, negative is not like negative numbers opposite to the opposite, like from 0 to below 0, it is negative.
Yeah,
It is
exactly.
just the direction, so
Yep.
it is not a negative number, but it's just direction of the
Just the
force.
direction, that's all it's representing. So
Yeah.
there's no such thing as a negative force.
Yeah.
Yeah.
You remember vectors? You
Yeah,
remember the
yeah.
vector? Each vector has a magnitude and a direction.
Mhm.
So the force is a vector or something like vectors.
Yeah,
So
yeah.
it has
Yep.
direction and a
Yep.
value,
Yep.
not only a value.
Yes.
Okay.
Yep.
Okay, Jonathan,
Good.
Jonathan is not with us. Okay. So is it clear
Mm,
up to now?
mm.
Okay. Okay, so the next one is also something related to mathematics. It is the notation of the numbers. So as you know, we can choose a number with different views or different notations. Okay, so in this question number 9,
Mhm.
so we have the number, sorry, we have the number 0.16 can
Mm.
be written in a scientific notation as 1.6. So 0.116, sorry, 0.16 can be written as 1.6 times 10 to the power k. Have you seen this scientific forms before for the numbers? This can be found on the calculators or on Excel sheets, spreadsheets. Okay, so this one form, scientific notation of the
Mm.
number, and another form on the Excel or Microsoft Excel, the number can be written as 1.6 EK. So we can write this value in two forms, 1.6 times 10 to the power k or 1.6 EK.
Mhm.
In the field below, enter the value of k. So what we want is find k. How much k? Do you know a method to find k?
I know what it is, but how do you find it? How do you find it? I know what it
Yes.
is.
So what it is? -1?
-1, yeah.
Yes. How I try to find a way to do it.
Mm.
So the way is we divide this value. So we have 1.16 to the form we want,
Mhm.
1.6, right?
Mm-mm.
So this will give us how many tens?
Oh, yeah,
So
yeah.
this will be how much? 0.1
Mm.
or 1 over 10. How can we write 1 over 10 to a form of 10 to the power something?
10 to the -1.
Yes, so it is equal to 10 to the -1. So how much k?
-1, yeah.
Yep. This is the way how to do it. Is
Yeah.
it easy or
Yeah.
want me to repeat it again? I will do another example to show you, but I mean this is how to find it. So I just divide the number we have over
Mhm.
the form we're looking for. So we give it like a value of number of tens, how many tens we need to write
Mm.
it in this form. So
Mhm.
how many tens we need? 1 over 10 or 10 to the power -1.
Mhm.
So k equal to -1.
1, yeah.
Another example or another form of it, if I want to write it as 160, so 1.16, I want to write it to the form 160 times 10 to the 4 to the power k or 160 EK. Or just change the change the symbol to make it, for example, J. So how much J?
-3.
Yeah, -3. Why -3?
Because you've moved the decimal place 3 positions across. That's all it is.
Yes, so
I calculate.
we will, yeah, we will do it again, 116,
Mm.
sorry, and over 160. So give us 11011. So it will become 10 to the power -3.
Yeah.
Okay,
Yeah.
so it become 160 e -3.
Mm.
Or another form, the last one. If you want to write it to the form, for example, point 0016 times 10 to the power I, or 1101016 EI. How much I in this case?
2.
2. Or in another way, so we have 6.16 over the value we want to show it, so 0016. So how much does it give us? This will give us 100. So how much is 100? 10 to the power 2,
2.
right?
Yep. Yep.
So I become 2.
Mm.
Okay, so do you understand how to find this? We need to divide the value, the actual value, over the form we want to show. So we will get numbers of tens. So this number of tens, sorry, here or here, will be converted to 10 to the power something. In the original example, it was -1. If we change the form, it become 2 and whatever. So it's up to you which form you want to show. Okay?
Mm.
But for this example here, so what we put in the box here, negative. What we put in the box here, -1.
Mm.
Okay?
Mm-hmm.
All good up to now?
Yep.
Okay. So our last problem, or our last question is this one here. So it has like a practice for. Sorry, I just want to. Yep, here. Okay, so this example has, we will practice all we have done through the class. So we will practice how to analyze the force to its component, vertical and horizontal component, and also will practice the equilibrium of at the point. Okay, so this example has two ideas, and this example is important for your formative and summative quiz. Okay. Okay, so if we read the example, what we have in this example here, in the drawing below, particle O or point O, so we have point O here
Mm.
in a static equilibrium. What does it mean by static equilibrium?
It's not moving in any direction. It's balanced,
Yes.
stays in place.
Yeah, actually, all the structure should be in equilibrium, otherwise it will be moving,
Mm.
right? So any point on the structure should be in equilibrium. How can we interpret this in equations? We interpret this in equation as 3 equations. Or for us now, we will only mention 2. What does this 2 means? All the forces in x direction, or summation of the forces in x direction, should be equal to what? 0.
Yeah.
So all the resultant of forces
Mm.
in x should be 0.
Yeah.
All the resultant forces in y direction should be 0.
Mm.
So what is meant by static equilibrium? All forces in x 0, all forces or summation of all forces in y 0, right? Okay, so now if we look at this problem, can we, from the first view, can we mention if it is under equilibrium or not? If you look at the equilibrium equation, what
Mm.
is in the equilibrium equation? Is there anything mentioned about inclined forces?
No.
So the two formulas, x and y forces,
Mm.
right? But actually what we have in our example, or our
It's inclined. It's on an angle.
inclined, so
Yeah.
we can't deal with inclined forces
So
because of the equilibrium
you
equation.
want to find the force in the A direction and see
Yes.
what that is. Yeah.
So this is the idea about inclined forces. You can't deal with inclined forces because of there is no equilibrium equation for inclined force. So you need to return it back to its vertical and horizontal component first before assessing its static equilibrium. Okay.
Mhm.
So the idea in this example, we need to inclined forces. will be analyzed to their vertical and horizontal
Mhm.
components, right? So it will be similar to our previous example above.
Mhm.
So if we look at this force, what we will do is we will find F1 vertical, right? And what in green? F1 horizontal, right?
Mm.
If we know F1 vertical and F1 horizontal, so we can assess the equilibrium, okay? And at this case, we will not don't need the original force F1. So the idea about analyzing is we canceling the inclined force and convert it to two components, one vertical and one horizontal.
Mhm.
So let's look at the example and to start. So first step is to find F1 vertical and F1 horizontal, right? So what is given to us? Given to us A 4 meter, B 3 meter. What is A and what is B? In this triangle here, this black triangle, this is A equal to 4 meter. This B equal to 3 meter. This angle is a right angle. Okay. So how can we deal with this? We will find the trigonometry. So we need to find the angle theta.
Mm.
So the first start is to find the angle theta. Theta doesn't mean or doesn't have to be the angle with the horizontal direction, right? Or it is a condition to make it with the horizontal direction. Theta can be with the vertical direction or horizontal direction, right? Is
See,
it
that's a
clear?
bit that gets confusing, Ahmed, because in the one of the exam in the previous question you worked it on the horizontal, right? But because the thing is that triangle there, that triangle is 180 degrees in a triangle, so 90 you can take away. So if theta was 30, then the other side would be 60. So doesn't that change? Doesn't that change your values?
No, but I will work with what you mentioned.
Yeah,
Okay.
if you did it the other way around.
But if you revise, I will just show you something
Yeah.
quickly. If you revise if we have this, so if this 30 and this 60,
Yep.
okay, this is
Yep.
what you mentioned, right?
Yep. But also on the other side of the right angle, it's 60 as well. So you put a right angle on the corner there, on the right-hand side on the bottom, or the
Yes,
top there, because it's 90, 180 degrees in a triangle. Therefore, you got 60 on the other side on a right angle triangle.
yes,
Yeah. Mm.
yes.
Yeah.
I understand you. If this
Know what I'm
30,
saying? Yeah.
this will be 60.
Yeah.
This is
That's
what you say.
yes. Yeah.
Yeah,
Yeah.
yeah. Okay, but I just want to show you something. How much sine 30?
Side theta is opposite over hypotenuse.
Yeah, sine 30 is equal to half.
Oh, okay. Yep. Oh, so it makes no difference. Half. Okay.
Yeah, equal to what?
60
Cosine
is half.
60.
Is half.
So
That's
sine
the difference.
30
Got it.
equal to cosine 30.
Yeah. Yeah. Yeah.
60, sorry. So it will give us same value.
Yes. 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 All right. Yep.
Do you understand it?
Mm.
Because both of them together, the summation of these two angles together,
Mm.
alpha, for example, and beta equal to what? 90 degree.
Yes.
Okay.
Mhm.
So I will just remove this part. But
Okay. Yep. 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 Yep.
yep. So if you want, I can work on this angle, this triangle. So
Yeah.
if
Yeah.
this triangle easier for you, so this will be B and this will be
Yeah.
A,
Yes.
right? If this B, so this B. If this A, so this A.
Yep.
Okay.
Yep.
So how much A? 4 meter. How much B?
Three.
3 meter.
Yeah.
So this our theta, right?
Yes. Okay. Got it.
So what you need to do for this type of problem, you will get the angle or the triangle outside.
Mm.
So I will take it outside like that. So we have our force F1. How much F1 given to us? F1 given to us as 105.
105, yeah.
Okay, so what we know that this is A,
Mm.
or this B, sorry, B 3 meter,
Mm.
and this is A, how much? 4 meter. This our phi, or theta, sorry. How can we deal with that? What we want to do is to find the component, the green component, F1 horizontal, and the other component, the yellow component, F1 vertical, right? How can we deal with that? We need to find,
The hypotenuse.
yes, the hypotenuse. To find what F1 horizontal and F1 vertical. How much F1 horizontal and F1 vertical before we start as trigonometry, using the trigonometry function?
Yep.
The vertical component, let's start with the horizontal component first. So what is the horizontal component? The horizontal component is close to the angle theta, right? So F1 horizontal will be equal to what? F1 times cosine or sine?
That one will be cosine.
Cosine theta.
Yeah.
Because again, this component is close
To the
to
thing. Yeah.
the angle
Mhm.
theta.
Mm.
Okay?
Yeah.
So we know F1, but we don't know how much is cosine,
Mm.
right? So we need to find cosine. The other direction, what is the vertical component is? It will
Yeah.
be F1 times, we have two option again. Yeah, sine,
Sine theta.
because theta
Yeah.
is far, so sine theta. Or
Yeah.
another option, as you mentioned earlier, you will go to find what? Alpha, for example,
Alpha. Yeah.
where alpha equal to 90 minus theta, right?
Yep. Yep.
Then it will be F1 cosine alpha.
Alpha. Yep. Got it.
Yep.
Yep. Yep.
So I just want to show you both because it might be easier to use one angle for
Yep.
both of them.
Yep. All good.
Yeah. So if the vertical component cosine, so the horizontal component will be sine.
Yep.
If
Yep.
the horizontal component cosine, so the vertical will be the other one, sine.
Yep.
Okay.
Yep.
So what we don't have up to now is how
Hypotenuse.
much is sine and how much cosine.
Yeah.
So we need to find the hypotenuse
Yep.
for this triangle. Can you find the hypotenuse for this triangle for me?
Yep. Okay. Yep.
So is this
It's
our triangle
it's
theta?
three.
This is the hypo.
So
This
it's
is
9
A,
plus
B,
16, which is 25. So it's 5.
5.
Mm.
So A 4 meter, B 3 meter. So the hypotenuse is 5.
5. Yep.
How? So the hypotenuse equal to root A squared plus B squared under the square root. So the hypotenuse equal to 4 squared plus 3 squared under the root.
Yep.
So it will be root 25 equal to 5 meter.
Mm.
So one of the interesting thing I want to share with you is that we have this triangle. It's called 3, 4, 5 triangle.
Yep. It is.
So
Yeah.
if we have, yeah. So if we have the one of the side 4, like the two sides of the right angle 3 and 4, so the hypotenuse will be 5.
Yep.
This can be also done for the for other, like what you call compounds of it. So for example, if this 8 meter and this 6 meter,
Yep.
what will be this
10.
10?
Yep.
And so on. If this 2 meter
Yep.
and this 1.5 meter, so this will be what?
3.
3 meter.
Yep.
And so on. So understand it?
Yep.
So this is called 3, 4, 5 triangle, and that's it. So after we found the hypotenuse as 5, so how much is cosine theta and sine theta in this triangle here?
So
So
sine
cosine will be adjacent over
hypotenuse.
hypotenuse.
Mm.
What is the adjacent? 3 over 5. So it become 0.6.
6. Yep.
For sine sine will be what? The opposite over the hypotenuse. So it become 4/5. So it become 0.8.
Yeah.
Right?
Got it.
So we have cosine 0.6, sine 0.8.
Mm.
So if we want to find horizontal component and vertical component, can you find them now?
Mm-hmm.
So F1 vertical component will be F1 times sine theta, right? How much F1 and how much sine theta? F1 is
105.
105
Mm.
kilonewton. What is sine
0.8.
0.8?
Mm.
So this gives us a value of 84 kilonewton.
Yep, that's right.
F1 horizontal, how much?
F1 times cos theta.
Yeah, F1 times cosine theta equal to 105 times what?
0.6.
0.6. So this gives us 63 kilonewton.
Something, yep.
Okay. What is the direction of these two forces, if you know, from the triangle here?
The vertical is positive, the
Yeah,
horizontal is negative.
upward
Upward
and to the left,
to the left. Yeah.
or positive and negative.
Mm.
Okay. So this is the horizontal. This is the vertical. Okay.
Mm.
Another reminder for you, if you have these two component and you want to find the force by reverse. So this just a practice for what you have know before from Pythagoras theory. So F will be what? F1 will be root F1 vertical squared plus F1 horizontal squared.
Mm.
So it become how much vertical? 84
80
squared plus
squared
63 squared. So what we should get?
105.
105.
Mm.
So if you know the force and you want to find the component, so you analyze using the trigonometry. If you
Yeah.
have the component and you want to find the inclined force, so using Pythagoras or Pythagoras
And double check your
theory.
answer, make sure your answer is correct. Yeah.
Yeah, this is one of the checks. Sometimes human error. So if your answer is not relevant or not logical, so you can review it like that.
Mm.
Okay.
All good.
All good up to here. So if we return back to our question, so what was the requirement? The requirement is to find how much is the vertical component and the horizontal component. So I will just, there is one picture missing, sorry. Do you have any question up to here, guys? Up to now? Any other question?
No,
No?
no, it's good. All good.
Okay. So I will put here. This is the requirement. So up to now, what we have found, F1 vertical, how much from above?
84, sorry.
Plus
84
84 kilonewton or 84. The horizontal component, how much?
minus
Negative
63.
63 kilonewton.
Kilonewtons.
So this upward and this to the left.
Yeah. Yeah.
What is the last part of our example here? After we
F2.
found, yeah. Now
Mm.
we need to find how much is F3 and F2.
Mm.
Okay, so after we found the forces, I will draw the diagram again. So this is our point O.
Mm, mm, mm.
We have now, this is our vertical component, F1 vertical, how much? 84.
Oh, yeah.
And this is our horizontal component.
63 minus
Yep.
63. Yep.
Yep. We don't use the minus here because
No.
now the direction.
Yep.
So if the direction is there, so no need for the negative, right?
Yep.
This is our actual force. F1 equal to what? 105 kilonewton. Actually, we don't need this one here. Why? Because we already have the component,
We got the
right?
vertical and horizontal. Yep. We got it.
Yep. Okay, so what else we have? we have F3
F3.
unknown and F2 unknown.
Hmm.
How much unknown could we have? This is just a question for you, quickly.
Well, if it's
Maximum
zero,
unknown?
yeah.
Hmm?
If it's
Can,
zero, then you have to get the opposite to what's there. So it's negative 84 in the vertical and negative 63 in the horizontal.
yeah, but I mean how many unknowns we have? One and two unknowns. So the
Two.
maximum unknown we can have only two unknowns. Why two unknowns? Because we only have, in this case, two equilibrium equation.
Yeah.
This is the idea. The unknowns
Okay.
need to be equal to equation, otherwise you will not be able to what? Solve them,
Yep. Yep.
right?
Yep.
Okay, so now what is the equilibrium equation we have? If you remember from the previous slide,
fx is
yeah,
the sum of fx is 0.
summation fx equal to 0,
Yep. And
sum
the
of
sum of
fy
fy
equal to
is
0.
0. Hmm.
So what is the force in x and what is the force in y? I will mark the force in y with yellow. So how many forces in vertical?
84.
Two. Two in vertical.
2. Yep.
How much in horizontal?
2.
Two.
Hmm.
So the horizontal will be using the first equation in green, and the vertical will be the second equation in yellow. So if we start with fx, summation fx equal to 0, what forces in x? F3 and F1 horizontal equal to 63.
Hmm.
So if I apply, can you help me to apply the formula?
So it'll be the sum of the two forces. So it's
Yeah,
F1
so I
plus
have
F3.
F3 plus this positive. Why positive? Because it is 2 right.
Hmm.
Right? I remind you with the direction again. So this is the positive sign for x and y. So if the force x to the right, so it is positive.
Hmm.
What about the other force?
It's negative. Negative F.
Negative. So why negative? Because it is to the left.
Yep.
These two together should be equal to what?
0.
0. So
Yep.
we have positive F3 minus how much F3? 63 kilonewton.
Mm.
So can you help me how much is F3 now?
83. It's this difference between.
This will go to the other side, to the left side, to the right side.
Yes. Yes. Yes.
Yeah,
Yep.
so it become
Positive.
positive 63 kilonewton.
Yeah. Yeah. Yep.
Okay.
Mm.
So this positive sign indicate what?
To the right.
Indicate it is to the right.
Yep.
Actually, it is not indicated only on the right. It indicates that our is correct.
The assumption's right. Yeah. Yeah. Okay.
Yeah. Okay, or it is to the right. Yeah, but I mean because in the future we
Mm.
will if it is unknown, like we don't know which direction it is, right?
Yeah. Yeah. Yeah.
But
Yeah.
here it is given directly to the right. But if you are doing this yourself, so you can assume it to the left or to the right, up to you.
Yep.
Okay.
Yep.
Okay. So this for summation fx. What about summation fy? How many forces in y direction we have?
2.
Two. This force and this force.
Mm.
So can you help me to do the formula? So F1 vertical upward. So upward is positive or negative? Y upward is positive. So this one will be positive. For F2, it is downward. So downward negative or positive? Negative, right?
Mm.
So why F2 should be negative? Because it is acting downward.
Yeah.
Okay. So if we apply Fy, so we have F1 vertical positive because it is acting upward. I try to put the arrow or the direction above to understand why it is positive. Okay.
Mhm.
What about the other force, F2? downward, so that's why it is negative.
Hmm.
This two together is equal to what? 0. Okay. So how much F1 vertical from our calculation earlier?
83, 84.
84. 84.
84.
So now we have plus 84 kilonewton minus F2 equal to 0.
Hmm.
So F2 equal to what here? So I will take this, put it in the other side here. I just try to move the negative, because when you move the negative to the other side, it become
Positive.
positive, right?
Hmm.
So we have now 84 equal to what? F2. So
Hmm.
F2 become positive 84 kilonewton. What is the direction of this force? Downward or upward?
How's F2 positive when it should be negative? It should be negative.
Yeah, this is what I was talking about in the previous one. So if we look now here,
Hmm.
what does this positive sign mean? This positive sign doesn't indicate the direction here,
Mhm.
because this come from equilibrium formula.
Mhm.
So this just indication that our assumption is correct.
Hmm.
What is our assumption is? F2 was assumed downward, right? So this was a assumption
Hmm.
given in the problem, right?
Hmm.
So
Hmm.
when this come positive, what this indicate? Indicate that actually this assumption was correct and the force acting downward or upward? Downward. Do you understand it?
That I understand it, but that's a little bit confusing, that last bit. But that's all right.
Yeah, I understand, but the problem is here.
Mm.
Why is he assumed downward here? This will maybe make it easier for you. Why I assume, or the question assume F3 to the right and F2 to the or downward?
Downwards, yeah.
Why? Can you explain to me?
Because it's acting in the opposite direction to the
Of the
vertical
force.
force and the horizontal force for the force of F1, because they're the
Yes.
coordinates. So we're looking at, because it's a zero equilibrium and it's the object's not moving, it's stationary, you have to balance it out. So it has to be opposite and equal forces.
Yes, that's right. So if we have this force, this is our actual force. So the component of this force will be this two, right?
Yep.
So to make this point under equilibrium, F3 should be in this direction and
Yep. Yep.
F2 in this direction, right?
Yep.
Yeah. So to make it for you,
Mhm.
if you want to make it what is the sign you get is the direction exactly, you should have assume F2 upward.
Yeah, yeah, yeah,
So if same example, but I assume like that.
yeah,
Actually, in our assumption, all our assumption, we
yeah.
will assume X and the force in X should be to the right
Mm.
and Y to the left. So
Yeah.
if I assume this F1 105, and what is the component was 84, and what is the component was 63.
Yeah.
So our assumption should have been this is F3,
Mm.
this is F2.
True.
Why should be upward? Because this our positive assumption. The problem is you assume it against or opposite to the positive. So when you get it from the equation, you get it positive. You understand what I mean?
So that's going up with the 84. So
Yeah. So
that,
if we apply summation y here, can you help me now?
yeah,
So we will have F2 positive because it is upward plus 84 upward equal
yeah,
to 0. So
yep.
how much F2 should be?
Should be negative.
Negative 84.
Cancel out. Correct.
Yeah.
Got it.
So this negative sign, what is negative sign indicate in this case?
Yep.
Indicates downward.
Yes.
So the negative sign here assume indicates
Yes. Yeah.
downward direction.
That makes sense now.
Yeah.
So it's a
But
substitution of the signs of the negative signs. That's what it is. Yep.
yes,
I
yes.
got it. Yeah, got it. That makes
So to get the what you want, negative indicates left and positive indicate right, and for y negative indicate downward and the positive indicate upward, you should make the assumption all the time in the positive direction like that, right and upward. The problem in the original example, it was assumed downward. So this is why the sign was reversed.
Yes, yeah. You see, when you do your calculations the way you do it, you substitute. See, I would have said that the sum of Fy would have been equal to F1 plus F2. And then I would substitute the actual forces, whether they be negative or positive, into that formula, and it gives you zero anyway.
Yes, that's it.
Yeah, anyway, doesn't matter. It is what it is. I get it.
So you want me to like do like that?
No.
So I will. This is what you mean? So
If I was
F2 plus.
writing the formula, I would say the sum of Fy equals F1 plus F2.
Yeah, the problem is sometimes in this case we have only two forces, right? But in some cases, for a structure, you will have maybe 4 or 5 forces
Okay.
in the formula. So if
Yes.
they are two, one should be equal to the other. But if they are more than two,
Yeah.
so it's hard to do it like that.
And when in a structure do you have more than two forces? Because typically, I understand when you're doing trusses, what you're doing the calculations now for trusses, this would represent the elements of the truss, the webbing, and the bottom chord and the top chords and things like that. But in structures, when is it multiple? Like what's an example you can give?
Okay, I will give. So no problem with this example now. Are you happy to continue? Because we
Yeah.
already exceed, but I am happy to.
Yeah, no, that's good. That makes
Okay.
sense. Yep.
Okay, thank you.
Mm.
Okay, so example for more
What's his
forces.
name? Jonathan, though. I don't know if maybe he wants to
Yeah, Jonathan, you are okay?
intervene.
Okay.
Otherwise,
Yep, that's good.
Yep.
Okay, so just one example. So for example, I will just show one small example here. If you
Yeah.
have a truss
Yes.
like that.
Yeah.
So what you have here,
Mm.
you have a reaction. You will have a reaction.
Mhm. Yeah.
And you might have a force as well. And what you have as well here, you have a force in this member
Mhm.
and also a force in this member. Okay? And so we have theta. Sorry, what's happening here? So this is our theta, and we have a force in this member.
Mm.
When I delete it deleted. Okay. From this come from something like that. I just extract it from a truss, as you
Yeah.
mentioned.
Yeah. Yeah.
So whatever the truss you have.
Yep. Yep.
So
That's
for
right.
example,
Yep.
yep, this one truss we have.
Mm.
So we have two supports.
Yep. Don't you love Microsoft? And then
So we will find the reaction and we have a force here.
Yep.
So what I have done, just extract this out to give me this part.
That one. Yeah.
So we will have, for example, here we have F1
Mm-hmm.
and here we have F2.
Mm.
Here we have a force, whatever the value is, for example, 10 kilonewton.
Mm-hmm.
Here we have a force, for example, 20 kilonewton.
Mm.
So what you will do first, you will need to find the two component of F2, right?
Mm.
I'll just try to make it simple as much as I can. So this F2 cosine theta, this F2 sine theta, right?
Yes, that makes sense. Yep.
Yep. So now if I ask you to apply the formula for Fy equal to 0, how many forces in Y we have at this point?
2.
This one,
And the bottom
this
one.
one,
10 and 20. Yeah.
and this one.
Mm.
So we have 3.
3.
So the equilibrium equation will be, for example, 20 upward, positive,
Uh-huh.
minus 10 downward, so negative, right?
Oh, yes. Yes. Yes.
Plus
Yep.
F2 sine theta. So this should be equal to 0. So
Yes.
now you can find F2 equal to, these two together will be positive 10. So send it to the other side, become -10. So F2 sine theta will be equal to -10.
Yes.
So F2 will be -10 over sine theta,
Theta.
for
Yeah.
example.
Yes.
Okay. Here, for example, if you go deep, here,
Uh,
for example, how many members you have at this point? And
there,
also we'll have a
5.
force. Yeah. So we have 1, 2, 3, 4, 5.
Mm.
So when you do the y and x, you will have more than 2 forces.
Oh,
The
wow.
equilibrium formula will have many
Yes.
forces.
Yes.
That's why you can't only depend on the
Yeah.
simple form of it. That's why all the time, even it is easy, so it's better to use the
Yeah.
like
But can I ask you a
the
question? Sorry, I don't want to hold you up, but you see, you're taking F2 as a separate force in that top chord or that raft, or it's not the raft, it's like a rafter. But I thought that the 10 kilonewtons that bearing down on that point, isn't that load coming from the truss itself?
yeah, it may be coming from other part directly on the column, for example, secondary beam or something else.
Oh, okay. So just secondary.
Actually, the force on the support will go directly to the support,
Yes, yes, yes,
so
yes.
it will not affect
So
the.
that's just an assumed coming from another load, so a beam in the different direction.
Yes, for example, a beam running
Yes,
in this
yes, yes.
direction.
Now I understand what you're saying. Yeah, got it. Yeah, I
Yep,
can see it,
yep,
but now I get that. Yep,
yep.
yep. That makes
I
perfect
just try to show you how
sense.
that we can have more than
Yes,
two forces in one equilibrium equation.
yes, yep, 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 yep. Got it,
Okay,
got it.
okay,
Thank you
that's
for that.
good. No worries. Are you okay? All good with the
Yeah, yeah,
session
yeah. No,
today?
it's all very good, very good.
Th-
Thank you for that.
That's
Um,
good. And Jonathan, are you okay? Do you have any other question, guys, today?
oh,
Other thing through the course content or any other query?
all good.
All good.
Yeah.
Thank you, Jonathan, and
If you've
have a
recorded
good.
this, Ahmed, if we're gonna have a look at it later.
Yeah, yeah,
Yeah,
sure. I will post the solution as well,
yep.
and I will post a link to the
Oh,
session.
thank you. But it was nice meeting you too, by the way. You and
Thanks.
Jonathan.
Yeah, thank you.
Uh,
I think Jonathan at work, so he can't talk much. No worries.
yeah, yeah, yeah.
Yeah, that's good.
That's all right.
And nice to meet you, Camilla and Jonathan, and
That's
have
thank you.
enjoy
Likewise.
the rest of your day, and we'll see
Back
you
to
in
back to
coming
work.
week. Thank
Work.
you so much. Thank you.
See ya.
Bye. See
Bye.
ya. Bye.
Bye. Bye. Okay.